problem, it says plot the following ordered pairs to form a quadrilateral. Classify the quadrilateral and support your classification mathematically. So first thing I'm going to do is I'm going to plot the points and label them as I go. So point A is at 0, 4. Point B is at 4, 6. Point C is at 5, 3. And point D is at 1, 1. And then I'm going to connect them to form the quadrilateral. And as we discussed yesterday, it looks like it could be a rectangle, but it's not enough just to say it's a rectangle because it looks like it. We have to prove it. So what are the properties of a rectangle? So if I think about what we learned through our project and our flow chart, I know that a rectangle has right angles, and I know that it has congruent diagonals. So if I can prove that those two things are true, I can prove this is a rectangle and not some other figure. In order to show right angles, I have to think about relationships between the sides. And so if angle ADC is a right angle, that means that line AD and line DC are perpendicular. So I can use slope to prove the lines are perpendicular. So I'm going to find the slope of each side. AD is a side, and I'm going to notate slope the way we did in class. I'm going to say the slope, which we usually say is M in algebra, of AD, the slope of DC, the slope of AB, and the slope of BC. And I can use the rise over run just looking at the graph, or I can plug in points into the slope formula. But this is a pretty easy one to find rise over run. So for slope of AD, let's see, I would go from D to A, I would go up 1, 2, 3 over 1. So that's a rise of 3, run of 1. And if I look at the line, it's moving downward as I move left to right. So that means it's negative. AB, let's see, from A to B I go up 2 over 1, 2, 3, 4. So up 2 over 1, 2, 3, 4. And as I move left to right, it goes upward, so it would be a positive slope. And side BC, to go from C to B, I would go up 1, 2, 3 over 1. And it's negative. All right. And DC, to go from D to C, I go up 1, 2 over 1, 2, 3, 4. So 2 over 4. And 2/4 reduces to 1/2. And negative 3 over 1 can just be simplified to negative 3. So immediately what I'm noticing is I do have a positive and a negative slope. So I have the opposite part for perpendicular, but I don't have the reciprocal part because it's not 3 over 1 and then 1 over 3. So therefore, it's not a rectangle. So my initial thought was incorrect. Now what I do notice is that opposite sides are parallel. AB is parallel to DC. They have the same slope. And AD is parallel to BC. They have the same slope. So I have just shown that it is a parallelogram. Now, at this point, I could take it further. A parallelogram also has opposite sides that are congruent. So if I wanted to show that, and I do because I want to support it mathematically as best as I can, then I could find the length of all the sides by using the distance formula. So AB and BC, DC, and AD. And I'm using this notation because remember, if we don't have the segment above it, it means the measure of AB. And then I use the distance formula. And before I start it, I just go ahead and lay out the general structure of the distance formula. So I'll put my parentheses, my squareds, my square root, and my minus signs. And the last one, AD minus squared, parentheses minus squared. Okay, so then it's x2 minus x1, y2 minus y1. And so for AB, A's coordinates are 0 and 4. So I'm just going to put them in here, 0, 4. And B's coordinates are 4 and 6, so 4 and 6. And then I'm going to use a little bit of mental math here. 0 minus 4 is negative 4. Negative 4 squared is 16. And 4 minus 6 is negative 2. Negative 2 squared is 4. So this would add together to be the square root of 20. Let's see. BC. B's coordinates are 4 and 6. So 4, 6. C's coordinates are 5 and 3. And then using mental math again, 4 minus 5 is negative 1. Negative 1 squared is 1. 6 minus 3 is 3. 3 squared is 9. So 1 plus 9 is 10. DC, D's coordinates are 1, 1. C's coordinates are 5, 3. And 1 minus 5 is negative 4. Negative 4 squared is 16. 1 minus 3 is negative 2. Negative 2 squared is 4. 16 plus 4 is 20. And then AD, A's coordinates are 0, 4. So 0, 4. D's coordinates are 1, 1. So using mental math, 0 minus 1 is negative 1. Negative 1 squared is in parentheses, so it's negative 1 times negative 1, which is positive 1. 4 minus 1 is 3. 3 squared is 9. So 1 plus 9 is 10. And I don't actually have to get the decimal answer because I can see easily that BC is congruent to AD and AB is congruent to DC. So even though I have the decimal answer, I know the square root of 10 is going to equal the square root of 10. So my conclusion, it said to classify the quadrilateral. So at first we thought it was a rectangle. We discovered it wasn't. So then we just bumped it up to parallelogram. So I'm going to say the quadrilateral is a parallelogram. And here's where it becomes not just some statement. It becomes a claim supported with evidence because I'm going to put because and I'm going to support it mathematically. So we have our claim, it's a parallelogram. Our evidence is because opposite sides are parallel